Forward to this computer. All right. Okay. Hey, team. Welcome back to World Video Bible School. We're gonna put my phone on airplane mode so I don't get texts. So I can give you all my full and undivided attention. So, fair, just in the sense of honesty, I've actually watched most of this video and I even recorded myself reacting to it. And it was so bad it broke my brain, and that video did not turn out very well. So what I'm just gonna start over and we're gonna talk about this. This is session 7 in their Science vs. Evolution series. Do dating techniques prove the Earth is old? Spoilers, yes. But just so you guys know what you're missing, in the first video last week we did 1 and 2. Did the universe cause itself? I haven't watched that one, but I am pretty darn sure it's a philosophy type argument. What does it mean for something to come from nothing? I'm not a philosopher, and I don't find philosophical arguments particularly interesting. Can life come from non-life and turn into you? That's going to be like, what is abiogenesis? How does that work? I don't know. That's not my field. So we'll put a pin into that guy. Do science textbooks prove evolution? This one is a particularly delightful little rant. I watched part of it, and it's a lot of PhD sideburns being upset that textbooks from which we teach children are not always perfectly up to date with modern science. As a rule of thumb for everybody, if science is sort of been around long enough to make it into a textbook, it's probably about 50 years old. So yeah, if you go pick up your kiddo's science textbook, it's probably about 50 years out of date. Now, some stuff doesn't change. Gravity still works the way it did long time ago, and we've understood how gravity works for a really long time. Human anatomy not changing. But in more modern fields like meteorology, our understanding of it has fundamentally changed in the last 20 years. It's growing by leaps and bounds. Biology is another field that's growing really fast. No, science textbooks are not always perfectly up to date. So sometimes they might present a theory that was later proved to be incorrect. And that's okay. I mean, that's maybe an argument for why we should want science textbooks to be more up to date, but okay, cool. But that doesn't prove a science textbook, again, from which we teach children, not being perfectly accurate or perfectly up to date, does not disprove a theory, right? So to me, it's really a moot argument. It was a very strange argument. And so now we're just going to jump into my wheelhouse. We're going to talk about dating methods. I am super excited to talk about dating methods. So they're like one of my favorite things. It's definitely rooted in my background in planetary science, and there's a lot of geology in planetary science. And then also it's related to my background in nuclear physics. So it's like almost everything that I like all in one happy place. So let's get to it. And we're still not going to see from this guy, this gentleman, handsome gentleman with a skull there on the title page, doesn't make an appearance. He is not, in fact, our host, and I feel deceived. I do. I feel deceived. World Video Bible School, false advertising. All right, so let's play. I'll put my pretty face over here in the corner. Maybe we'll make this full screen. Oh, there we go. Beautiful. Look at that. Oh, I hope. Here we go. Okay. Okay, sweet. I think that should.
In order for a theory to be true or an idea to be rational, it has to have supporting evidence. The proof
Definitely agree with you there. I don't really want to listen to you wax poetically about what is and is not rational. So these, by the way, are the things that are apparently wrong in textbooks. I don't know. I think they're not quite right on some of these, but we're down to this last one of dating methods. Um, so let's talk about dating methods. All right, and he's gonna spend some time here talking about assumptions. And I think his stance is that they are bad.
all the time in order to be able to solve problems and figure things out. And assumptions can be fine and good to that end, as long as the assumptions are reasonable and have a small enough effect that the outcome of the problem isn't drastically affected by the assumption. Let's
Okay, so he's not wrong, right, about talking about assumptions like this. And in fact, this is like what every Physics 1 student learns, right? Write your assumptions about the problem at the top of the test. If you don't do that, you're probably not going to pass Physics 1. And so this idea that like you need to understand any and all assumptions that you're putting into your model or your equations or whatever it is you're looking at. Um, and know how those assumptions are going to affect the outcome. I think a great example of this is going to be in the world of fluid dynamics. In the world of fluid dynamics, the set of partial differential equations that govern how a fluid behaves is called the Navier-Stokes equations. Navier-Stokes equations. Fun fact, if you can solve analytically as opposed to numerically, analytically solve the Navier-Stokes equations, you can win $1 million. It's a well-established unknown in math land. So let's see. That's, you guys should be able to see that. But these are the full equations. This describes behavior of a particle. Oh, you know what? Let's just leave it in the Google search. I don't want to go to whatever website. So this is, so the density of the fluid times the change in the velocity vector with respect to time. That's the local change, plus, this is density again. And then this is, okay, so this is the velocity dotted with the Laplacian times the velocity again. So what this gets at is, I would probably call that, no, that's the curl, never mind. So this is another type of acceleration. This is basically how the fluid moves itself, is the best way I know to describe that. And then, so this left-hand side describes like, this is how the fluid moves. How the fluid moves is related to the pressure gradient. That's going to be a force exerted on the fluid by this pressure gradient times a body force term. So that's like if you have something, I don't know how I'm pushing air in this example. I'm physically applying a force on the body of the fluid, a body force, and then plus the viscous term. So this set of equations, super complicated. Very, again, you can't solve it with a pen and paper. There is no answer that way. You can sort of brute force your way through it with a computer. So that's great. But it turns out if your fluid is very viscous, so a fluid with high viscosity, an example of that would be like molasses or honey, then it turns out that this viscosity term is pretty much the most important term on this right-hand side. And that whole massive gross equation is going to reduce down to just the Stokes equation. Stokes flow. Let's do Stokes flow. Let's Google that. And I am going to once again, maybe my face should live down here in the bottom left. Let's go ahead and pop over to images. Stokes flow. Maybe I should add equation to my search. What do you guys think? Okay, let's do that. Here it is. Yeah, so it's the change in pressure is equal to, this is a viscosity constant times the Laplacian of the velocity field. So This sucker, this whole bit of nonsense, reduced very simply to this, and that's it. And this is a level of math that was a class project, code Stokes flow for flow around a solid object, versus Navier-Stokes, the full set, which will, if you can possibly solve that, you get $1 million. So, sorry, that's a very kind of rambly example. So my assumption that my fluid was viscous, because my fluid was viscous, made my life a lot easier, right? But I didn't make that assumption sort of blindly. I didn't do it just so that my life would be easier. So for example, in atmospheric science, we do fluid dynamics all day long. That's what we do. But viscosity is, the viscosity of air is very, very low. That's a low viscosity fluid. So we don't make that assumption because we know better. And so what he's really doing here in this discussion of assumptions are okay as long as you're really careful is he's implying that scientists who deal with dating methods aren't careful with their assumptions, right? He's priming us to believe that. And I find that dishonest and I don't like it. And so again, the notion that not just a self-respecting scientist, but a whole discipline of science with lots and lots of scientists in it, all invested in sort of keeping each other accountable, that none of them thought about their assumptions is frankly really insulting. It's insulting, it's dishonest, and it's inaccurate. So he's going to ramble about, I think he rambles about assumptions for a little while longer. So let's just sort of jump ahead a bit. Oh, okay, yeah. So, sorry, I watched part of this before. He gives an example about if you design a car to work on on a really well built road, and then you put that car in an off-roading situation, but you didn't change any of your assumptions, then it's not going to perform well. Accurate. That's a great example of why assumptions are important. But we don't need to listen to this story, and especially when we know what he's doing. He's trying to prime us to believe that the assumptions behind dating methods are not good. Spoilers, they are. They're very well reasoned, and I'll go through it with specifically uranium lead dating of zircons, which he is going to talk about. Okay, let's just let him talk a little bit.
Nowhere with no road, and I want to.
Nope, not far ahead enough. Okay, so okay, I think okay, then here he brings up uniformitarianism again. And so last week, so uniformitarianism is literally not something I had ever heard before I was reviewing the first couple of videos of this series last week. So it's not a thing that's actively taught, and it's not a point of view. So I don't know what his point is, and honestly, bringing up such an antiquated term, it's seriously like 100 years old. Such an antiquated term, to me, just speaks of volumes about either his own lack of education, right, in this, his own just lack of knowledge, or being intentionally dishonest, intentionally using antiquated terms that, again, no one thinks or believes. So, what I thought he meant was like things behave now the way they used to behave unless we have a good reason to believe otherwise. And so that concept is true, and we'll get to that and why that's important for specifically for dating as we move forward. But I just want to mention that like this whole he's harped on uniformitarianism a lot, and that's like I don't know, it's sort of like harping on why phrenology is bad. Phrenology, right? That old school, like the size of the skull tells you about how smart a human is, or like if you can test like the lumps and bumps of your skull. That's nonsense. And we know now that that's nonsense. It was once believed to be true a very long time ago when corsets were in vogue, right? Okay, So I don't want to listen to him talk about uniformitarianism. Let's get to some dating methods.
Uniformitarianism,
No,
is this idea a reasonable approach in dating the Earth? Is uniformitarianism
it's not an assumption we're making though. So
of years to complete, but more and more scientific evidence is coming to light, which proves that the rate of petrification can be significantly altered by catastrophic events.
okay, that's factual. So you guys have probably all seen, oh, what's the like the petrified boot, right? Petrified boot. This is a favorite of, I think, young Earth creationists. Yeah. So um I think this is it. It's often used, again, you're seeing evolutionismmyth.com, young earth evidence, limestone cowboy boot, fossilized cowboy boot. So mineralization occurs when so minerals, say like in if you have highly mineralized water, that gets in and sort of binds to and interacts with the thing like a boot. um let's look. This is also how you get petrified forests, how you get petrified trees. So this type of petrification occurs much faster than, say, the process by which a dinosaur fossil forms. So when bone turns into rock, and that's really my understanding of that, is that these are just different processes. But that is not what we're here to talk about. We're here to talk about dating methods. Um, so let's try to get to some dating methods. Petrified wood is a thing which exists. Um, petrified wood does not take millions of years to form. Dinosaur fossils do. Different processes, different things. That's kind of my long and short of it. And since that's not my field, that's all I'm really comfortable. That's the depth to which I'm comfortable talking about this. All right, there's some scripture. That's fine, but it's not scientific evidence. Hey, look, there's the ark. What are we going to say about the ark? What do you have to say, dude? Once again, we're like 8 minutes into this video, and he is
The universe.
yet
The creation model doesn't require
to bring up dating methods, dating techniques. We have yet to bring up a dating technique. And we're like almost a third of the way through this video, which is quite frustrating, but I do think speaks volumes to how few points he actually has and what little evidence he actually has. All right.
that drastically affect any dating schemes attempted by geologists.
Okay, so I think the point he's getting at here is like, if Noah's flood is a real thing that happened, then that would really mess with dating techniques. I came here to talk about uranium lead dating, and no amount of water is going to change that process. So maybe I don't know enough about like how geologic catastrophes, what sort of fingerprints those leave in the rock. I don't know enough about that to be able to say what a global flood, which is not a thing that has ever happened, but what that would, in theory, what evidence that would leave behind. Because that certainly would leave behind evidence. If not the Grand Canyon, not not the things that they tend to point to. But that also wouldn't affect uranium lead dating. And it wouldn't affect, there's a lot of things that would not affect. Most radiometric dating wouldn't be affected. So. And again, I'll talk more about that once we're talking about the uranium lead
interpreting
dating.
Geology is that there's no way to get an accurate reading of the age of anything very old except through divine revelation.
Divine revelation is not a scientific method, my dude. Let's get that full sentence. I was surprised by that. What did you
The
say?
implications of the catastrophic approach to interpreting geology is that there's no way to get an accurate reading of the age of anything very old except through divine revelation.
We don't know, so we have to ask God. And whenever, no, that's not real life, my dude. That's not. And also, that's also a specific claim. We cannot know the absolute date of anything that's very old. Can't possibly know that. That is a claim that requires evidence. Show it to me.
So be it. If that's where the evidence leads, that's where it leads. And it would be unreasonable
It's
to
not where the
accept any
evidence
other
leads, dude.
option not in line with the evidence. The bottom line is that rapid petrification alone disproves the false theory of uniformitarianism.
Rapid petrification of uniformitarianism, which is not a thing.
An unreasonable assumption. Natural catastrophes seriously affect all dating assumptions. Catastrophe.
That's not true. Natural catastrophes don't affect all dating assumptions, right? So notice what he's saying. And that's also, so if you're listening to anybody and they say things like all, never, always, that speaking those absolutes, that is something that you should uh, be wary. That's a statement you should be wary of. That should trigger a little bit of disbelief, of skepticism in your brain, because there is, haha, I'm about to do it. There is almost nothing that's always true, almost nothing that's always false, right? There's sort of always cases and scenarios. And so what he just said is catastrophic events without being specific about what type of catastrophic events, right? Always or affect all dating methods. He has not listed what dating methods we're talking about, right? And so that's definitely not true, right? Like a dating method, not necessarily for like of the earth, but of the universe, has to do with starlight. What in the world does a star 10 billion, 10 billion light years away care about a flood on planet Earth, right? So he's being very, very vague, but making really grand claims. And so that's some nonsense. That's some nonsense, is what that is.
Like local floods and the global flood of Noah's day, volcanic eruptions, plate tectonics and their effects, especially tectonics possibly caused by God himself on day 3 of the.
Plate tectonics are very cool. Plate tectonics, again, I don't know what he means by like, does he think geologists don't know about plate tectonics? Does he think we didn't think about that when we were coming up with dating methods? And also, so one very cool thing about plate tectonics is that's the movement of plates and like subduction of plates is a great way to make new crust, to make rock. And so that's a place where rock is made, but then we can date that rock, right? After enough time has passed, for half-lives to decay and all that, or for elements to decay, et cetera, so forth. But that doesn't, plate tectonics don't change how uranium lead dating works. And I know I'm harping a lot on uranium lead dating and other forms of radiometric dating, but those are, like, I guess he didn't explicitly state that we're here to talk about absolute dating techniques, but I assume that's what we're talking about. So an absolute dating techniques is a way to get like a year. This is when this happened. This happened 4 billion years ago, versus relative dating techniques that are just like, okay, I know this has to be older than this because blah. My favorite example of a relative dating technique is how we look at surfaces in the solar system, and that's to do with crater counts. So the more craters a surface has, the older it tends to be. So if you have a surface like the Earth, we have very few craters compared to the moon. So that means the crust of the Earth has to be younger than that of the moon. Why is that? He just said it, plate tectonics. We recycle our crust, we make new rock. The moon doesn't. The moon, what has been on the surface of the moon has been on the surface of the moon for most of its history. And there are places on the moon that are less heavily cratered than other places. So that tells us something interesting about the geologic history, but it doesn't tell us when exactly that surface formed, just that it is younger than the other one. Hope that kind of makes sense. But so relative dating shouldn't be a problem for young Earth creationist folks, because it doesn't say how old something is, just that it's, hey, the bottom layer is probably older than the top layer, right? That's it. It doesn't say how old they are. Absolute dating techniques, mostly radiometric dating. There's other clocks, but radiometric dating is my favorite and the one I know the most about. So that's what I'm going to chat about. Radiometric dating is not going to be affected by a flood, is not going to be affected by a volcano, is not going to be affected by plate tectonics. Like, none of those things will affect these processes. It might make new rock, right? That's what those will do. But it doesn't change how a rock once made will decay, right? How the atoms in that rock will decay. All right, let's let him talk.
Week. Who knows what God might have done pre and post flood that could have affected the Earth's decaying processes?
I'm going to start calling this an appeal to magic, right? Gandalf could have waved his staff and made so many uranium atoms appear. We don't know. So that's not a scientific claim, is my point here. So if it's not a scientific claim, it's not a testable claim. So that does not belong in a discussion titled Science versus Evolution. The entire grounds of dating the Earth as millions of years old falls. So this statement is nonsense. One, the Earth is not millions of years old. It is 4.5672 billion years old. So much older than millions. That's much older. Once the assumptions of uniformitarianism is shown to be inaccurate, so the entire grounds for dating the Earth as old falls. So that statement is false, right? Because as we said, that like uniformitarianism is not a thing. That's not a thing anymore. And also, uniformitarianism, I think, originally had something to do with like geologic processes. That was a thing that was in vogue well before radiometric dating existed. So, sorry, this whole sentence, these two sentences are just so full of inaccurate nonsense that I don't even quite know where to begin with it. So he's saying that all of our dating methods are rooted in uniformitarianism, which they are not. Therefore, if uniformitarianism isn't true, then these things can't stand, but they're not rooted on uniformitarianism. Here, this is the picture I'm imagining in my head. Let me draw a picture for you. I think this is what he thinks. So we've got a house, and we're going to build that house on a foundation. And let's say that the house is, we'll name it Age of Earth. Cool, right? Look, it's a house and it's on a foundation, right? And I think I spelled uniformitarianism incorrectly, but then over here we have a separate concrete slab of uniformitarianism. And he's like, see, somebody's gonna come up and like shoo that away. Shoo. I think that should be maybe shoo with O's. Shoo, go away, uniformitarianism. And then it goes away. And then he's like, see, I kicked out your foundation. And we're over here hanging it out in our house, being like, dude, wrong foundation, wrong house. So that's what this sentence looks to me in a cartoon form that's still breaking my brain. It's fine.
Uniformitarianism is shown to be
No, stop talking.
built on the assumption of uniformitarianism.
No, it's not.
According to evolutionists, in order for evolution to be true, the Earth and life must be very old, millions of years. The truth is, time won't help. Sit around staring at a rock for millions of years, and you can be confident that it won't grow legs and start walking.
No one is suggesting that humans came from rocks. No one is suggesting that. No one is suggesting that a rock might spring legs. Does he not think that things like you have rocks and then plants and animals? Does he think that's all that exists on a planet? Like really? That's all you think exists. That's not how this works, dude. Like, it's just not. Okay. Sorry. He is exhausting. He is seriously exhausting.
Techniques such as radiometric dating for inorganic
Radiometric dating. Yay! Let's talk about it.
materials, carbon dating for organic materials. If these techniques are shown to be invalid, then the entire basis for proving an old Earth crumbles. In an earlier session,
I mean, it's not like this is the one thing. There's like 12 million things that all co-support the idea of an old Earth, right? Radiometric dating is best way we have to get an absolute date, right? That's how we know the Earth is 4.5672 billion years old. All right, talk to me.
Discuss the first and second laws of thermodynamics. The second law indicates that the universe is running down. We're running out of usable energy.
I don't need to go back into this, right? Like last time I ranted about how he doesn't understand the second law. I've got to skip through this or I'm going to like repeat. Why is the periodic
breakdown appears to be at constant rates today? For example, potassium breaks down into argon.
Okay, wait, sorry. I think I actually missed something.
Itself is breaking down, and scientists have discovered that elements on the periodic table break down or decompose into other elements on the table over time. And the breakdown appears to be at constant rates today. For example, potassium.
By the way, did you hear that the breakdown appears to be at constant rates today? He slipped that in. So this is radiometric decay or radioactive decay is the process by which you have one element decay into a more stable element. There's lots of different types. I've got a whole video series on those, but so alpha decay, beta minus, beta plus, those are the most common. Spontaneous fission is a fun one. And so they decay. Sometimes it just decays to a different isotope. But sure, it's often different elements. When we're talking about radiometric dating, we're talking about decay to different elements. So basically really heavy elements like uranium are unstable. And now unstable, like sometimes that's on geologic time. The half-life of uranium-238 to lead-206 is 4.5 billion years. So if you dug up some uranium and held it, it's going to be pretty darn stable. But if you wait 4.5 billion years, it's going to decay. Time scale matters. Also, that thing he slipped in about they appear to be decaying at a constant rate today. Lots and lots and lots of people have tried to accelerate radioactive decay or slow it down, and no one's been able to do it. Temperature doesn't seem to affect it, neither does pressure. You could maybe accelerate it if you no, you could change the type of decay is what you could do. But like if you're just looking at a decay chain, that's a very stable, constant thing. And if you could demonstrate changing a decay constant, right, or that a decay constant has changed, you would win a Nobel Prize, right? That is the level of amazing, awesome discovery that would be. So him just kind of slipping that in of they appear to be constant today, again, implying without actually saying that they maybe used to not be constant, is very dishonest and is in itself an extraordinary claim requiring extraordinary evidence. So I want to see it, PhD Sideburns. I want to see your evidence. Want to see it.
Down into argon, uranium into lead, and rubidium into strontium. The starting element's called the parent element, and the element after the decomposition is known as the daughter element. Scientists are able to measure the rate at which the parent isotopes decay into the daughter
Mhm.
isotopes with an amazing degree of accuracy. The problem is that dating techniques like these become more and more inaccurate in telling ages the farther back they try to predict age. In other words,
Okay, so that's dishonest, PhD sideburns. It's sneakily dishonest. I don't like it. I want to like you, buddy. I really do. I like most people. But you're being like, things you're saying in this are more than a little slimy. They're more than a little dishonest. And I assume, since you have a PhD and you're talking about these subjects with some air of authority, I assume you know better. And so I don't like it. Okay. So I told you earlier that the Earth is 4.5672 billion years old. Um, so written out like long form, right? That's 4,567,200,000 years old. Okay. The margin of error on this number is at that 2. Okay. So we know something is 4 billion years old, and the margin of error is at the 100,000 year mark. Okay. Now, an error of 100,000 years probably sounds like a lot, but not when we're talking about 4 billion. That would be the same as like, I have $1,000 plus or minus 10 cents, right? If I have $1,000, I probably, that dime, the getting it down to the right number of dimes and pennies doesn't matter a whole lot. So what he's talking about here is that, so sort of our percent, think of the percent accuracy is going to stay the same. But the further back you go in time, the larger that percent is. That doesn't mean it's like less accurate. This is we don't measure, so you don't measure like the speed at which you run a mile with the same precision as somebody would try to measure like how fast a hummingbird's wings flap, right? You can even use different tools to measure that. You can use a stopwatch to measure how fast you run a mile. And maybe you don't care about a second, or maybe you do care about your seconds, but you maybe don't care about a tenth of a second, right? But a hummingbird flaps its wings like a tenth of a second matters, right? A tenth of a second is, it might be the whole flap. So measuring different scales, different sort of margins of errors are appropriate. And that doesn't mean the dating method is bad. And it's not that like we don't know something happened yesterday or 200,000 years ago. It's, we know that it happened 4.5. We know we have either $1,000.20 or $1,000.05. Right. That's so we know that the Earth is 4.5672 billion years old. Maybe it's really 4.5675, right? But that's a very small margin of error. And it is hard to think about long time. Geologic time is a tricky concept. And thinking in really big numbers and understanding how big they are is surprisingly difficult. But that statement's dishonest. So, for example, another example on this is going to be carbon dating. So, carbon, the half-life of carbon, carbon 14, gosh, sorry, brain fart, is about 6,000 years. So we can accurately measure ratios until we have about 10 half-lives have passed. So that means that the oldest we could date something with accurately with radiocarbon dating would be up to 60,000 years ish. I'm not specifically in that field. Maybe they've gotten better. Maybe it's really to 100,000 years, but it's not going to be to a million, right? So a margin of error of 200,000 on a maximum 60,000 year measurement would be really terrible, right? That wouldn't be good. So that's not the margin of error for radiocarbon dating. It's more, I think it's in the hundreds of years. Don't quote me on that, but it's something like that. So, yeah, something could be 47,500 years old, but maybe it was really 47,600 years old, right? And it is also true that the closer to the present, the more precise we can be with our measurements. It's just kind of the nature of the beast. But something can be, just because our age of the Earth isn't as precise, isn't down to the hundreds of years as our measurement of, say, oh, I don't know, what's something old ish? The wood from a shipwreck from Vikings. I don't know. Something like 1,000 years ago. Um, so just because it's not as precise doesn't mean it's not as accurate, right? Precision and accuracy, not quite the same thing. I hope that makes sense. And again, it's guys, it's really, we know it's 4.5 billion years old, right? We really, really do know the Earth is that old. We really know that. We've measured multiple things with multiple dating methods to be that age. We've both measured terrestrial rock to be that age. We've measured asteroids to be that age. We've measured moon rocks to be that age. We know that's how old the solar system and the Earth is. All right, let's let him talk.
Become less and less likely to predict the actual age of a material
Not
the
true.
older the object appears to be. And one of the
That's
reasons
a lie,
evolutionists
PhD
themselves
sideburns. I'm not just
dating
gonna sit here and
methods,
let you lie.
they find that different dating techniques can yield significantly different ages for the same rock. Sometimes
Tell me, what do you mean by significantly different? Because in science land, that means things. So this is a claim that you need to bring specific evidence for. And he's not going to do it. I guarantee he's not going to bring it.
differing by even millions of years. And one of the primary reasons for this problem is the effect of incorrect assumptions in the dating methods that
Prove it. What incorrect assumptions? So let me tell you guys assumptions that go into uranium lead dating. Let's just talk about it. Okay. So there are a couple assumptions. So when we use uranium lead dating, we use it on a very specific type of element, and I think I've got it pulled up here. This is the chemical structure of a zircon. Oh no, I want a picture. No, that's just a periodic table. That's not helpful. Here, yes, this is what I want. Okay, so we're very intentional, scientists are very intentional about what even specific minerals they date. So they usually use uranium lead dating. A zircon is your gold standard. So let's talk about why. So this is the crystal structure. This should look like maybe a ball and stick model of atoms that you made when you were in like middle school or something like that. So all of those red balls represent oxygen atoms. The gray balls are zircon atoms. The teal ones are silicon. And then the sticks represent covalent bonds between them. And so notice here that zircon has this +4. So think back to like high school chemistry, guys. That's how many electrons that zirconium would sort of like to get rid of. It wants to share 4 electrons to fill out its outermost orbital. And fun fact, team. So let me show you. So here we go. Oh, here we go. Here we go. Here we go. Look how prepared I am. I had these pulled up. I'm very proud of myself. All right, so check this out. Here's zirconium. That's what we're interested in. And let's kind of count where it is from the left. Because remember that each row is going to represent like an orbital. And we want happiest atoms have full orbitals, or happiest molecules have full orbitals. So this zirconium is 1, 2, 3, 4 from the left. Oh my goodness, +4. It's almost like we set up the periodic table intentionally. And now uranium is down here. So check out uranium, 1, 2, 3, 4. Ooh. So punchline, uranium can, in a chemical reaction, Or in building a crystal structure, let's say it like that. When you're building a crystal structure, these bonds you're building, really the thing that they care about is that those number of electrons that they kind of either want to lose or gain to fill out their shell. Um, so to a crystal that's being formed, a zirconium atom, oh, I didn't mean to zoom. Oh no. A zirconium atom looks the same as a uranium atom. They have the same number of electrons to share. So when we're building this guy, anywhere you see a gray atom, a gray ball, we could toss in a uranium atom. Uranium isn't super abundant, so we're going to have a lot more zirconium than we have uranium, but uranium can be incorporated into this crystal structure, no problem. It fits in just like a happy puzzle piece. Okay, and uranium over long periods of time will decay eventually into lead. Uranium 238 decays to lead 206. Uranium 235 decays to lead 207. Half-life for uranium 238 is 4.5 billion years. Uranium 235 is 1.1 billion years. So let's take a look at lead. Where would we find lead on this table? Here we are. And we don't need to be geniuses to note that lead is in a very different column. It's in a very different spot than zirconium and then uranium was. Okay, so what that means is that from our crystal structure point of view, when we're making this zircon, we can swap a zirconium atom for a uranium atom, but lead won't fit. Lead is square peg, and this is a round hole. So uranium will fit, lead won't. So it is a reasonable assumption that when this crystal, this zircon formed, there was no lead, right? And we understand that from the chemistry. So what we can say is that any lead we measure in a zircon today got there by radioactive decay of the uranium. So sometimes when we're looking at this zircon, we'll see a lead atom where there shouldn't be a lead atom. And the only way that was going to happen was by radioactive decay. So I'm gonna let's let him talk. Let's let him talk and see if he explains what I just did about why daughter concentration for specifically uranium lead dating of zircons matters and is a thing we can know.
Evolutionists use. As I explained a moment ago, assumptions oftentimes have to be made in science in order to be able to have enough information to solve a problem. However, the key is to make assumptions that are reasonable and that won't significantly corrupt the end result. The problem is that evolutionary dating techniques don't make reasonable assumptions. Evolutionary dating techniques are based on at least 3 specific unreasonable assumptions that do significantly affect the end result. In this case, the age of the item being tested. Take, for example, the uranium lead dating technique. Uranium decays into lead over time. What are the assumptions that go into getting an age for a piece of uranium? Number 1, the nuclear decay rate of the element.
So the nuclear decay rate has been constant throughout history. Again, I said this earlier. We, no matter, even in a lab, right? No scientist, no physicist has ever been able to change the decay constant. So if you want to say that that's a bad assumption, you need to tell me how it would change and then go collect your Nobel Prize, right? Because that would dramatically change our understanding of science and that would change our answer. But we have no reason to believe that the decay constant has been anything other than constant throughout history. What are his next points? Excuse me, goodness. No daughter element existed in the specimen being measured at the beginning of its decay. So that's why you don't just uranium lead date any old rock. You're very intentional about which rocks you choose because we know for a zircon, we can make that assumption. That number 2 is a very good assumption. All right, so those 2 assumptions feel fine to me. If they don't to you, let me know down in the comments. What's our third assumption? The parent and daughter isotopes have not been altered by anything except radioactive decay. Maybe we should let him talk because I'm not quite sure what process are you proposing would change these concentrations? Um, I can't think of one. Zirconium specifically, excuse me, zircons, that mineral is very, very resistant to weathering. It's a very robust mineral. There are other types of minerals and rocks that are not, they get broken, they can be affected by things, right? If Look, if a zircon got shot out of a volcano, the volcano actually probably didn't affect the zircon. If a basaltic rock shoots out of a volcano, that basaltic rock was just formed. So if you know anything about geology, you know some of this stuff. It is possible to destroy a zircon. It's just harder than other minerals.
Isotopes have not been altered by anything except radioactive decay. In other words, the amount of the elements present in a sample haven't ever been affected by any outside element. So,
So I guess my question here is like that would matter a lot if we were thinking about how much lead was in this, right? So we established why lead can't sneak in there during formation, but he's saying maybe sometime over the last 4 billion years some lead got in there. Cool. How? Please describe that process to me because I don't know how you do it, right? Um so like those so with his points here, those are three assumptions that are made about radioactive decay, and those assumptions certainly inform which minerals and rocks scientists choose to date and why they choose to not date others, right? um if you wanted to know how how fast a hummingbird flaps their wings, um, you would this analogy is getting out of hand very fast. I'm just laying down track and keeping talking and hoping something sensible comes out, but it's not gonna happen. So I'm gonna stop. Anyway, so these to me really feel like valid assumptions, and especially when care is taken in what we choose to date, which things we date, right? So I do just want to show you guys the math. I don't know if he's going to get to it. So let's do, and I always forget this one. What is the radiometric dating equation? It's the daughter one that I can never remember. Oh, okay. There we go. So, all right. So yeah, daughter is equal to daughter concentration initial plus this is the Woods Hole Institute out in Cape Cod. They're very cool. um and yes, okay, that's what I thought. So this is the daughter is sorry, they're using in here to represent the parent. um eh, and I was using p in what I'm writing down, so I just want to be consistent. E to the minus lambda t. Okay. All right, team. We'll pop over here. So hi, hello. Look at my happy. Um, this is the equation. So the concentration of a parent, right? So in our example, the uranium isotope is equal to initial concentration. So how much we started with times e to the minus that lambda is the decay constant, and then times the time elapsed. And then the daughter concentration at time now is how much we started with plus how much has decayed from here. So that's our equation. And so there's a few things that we do need to know. We need to know the decay constant. That's a thing that we can measure. Cool. That's some poor graduate student or poor researcher that spent their whole life coming up with the one number, right? We need to know the initial daughter concentration, but we picked a zircon, so we're smart. So that initial daughter is 0. And then we need to know the initial parent concentration. And that's not a thing that you can get straight out of a rock that you dug out of the ground. So how do we deal with that? Well, that's why uranium lead dating is so cool, because we have 2 parents and 2 daughters. We have uranium 238 and uranium 235 that decay to separate daughters, lead 206, lead 207. And we also know the relative abundance of uranium 238 versus 235. So if you go dig up a bunch of dirt, something like a 98, no, even more than that, 99 point something percent of that of the uranium in that dirt is going to be uranium-238, and a very small percentage, I think it's like 0.3%, is going to be uranium-235. So that's very cool. So we know those relative abundances, right? And so if we know how much we have now, we know those different decay constants. Basically, the initial concentration of the parent you can solve for because we have two clocks running and we know how they related to each other when they started. So that I find that very cool. So we don't even need to know the initial parent concentration because we have these two isotopes going. All right. All righty then. Let's. I do have a video on this. It's called like Uranium Men. It's a pun on it's raining men. It's a very clever, I assure you. All right, all right. What else do you have to say, dude? What do you
Example,
got?
a lava flow didn't occur, which could have picked up some of an element from elsewhere and added it to the sample.
Please tell me how a lava flow does like fusion. Like, please. I guess it wouldn't be fusion, but like, please explain to me. Please explain that to me. So you have a rock, right? And it's picked up by some lava, okay? And if the lava melts the rock, then we don't have the rock anymore and we can't date it, right? Can't happen. So then that's gone, but the lava chucks lead into it. Is that what you're saying happens, PhD sideburns? Somehow lava has the ability to throw lead atoms into a zircon crystal structure? But how? 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 I don't understand. I don't understand how this is supposed to work, my guy.
Measured or taken some away, thus corrupting the accuracy of the measurement. Now,
How?
common sense tells us
God.
that these are pretty grand.
Common sense is not a valid research methodology, dude. You should know that. Gah.
Those presumptuous assumptions in the older rock
They are not presumptuous. I just explained them.
is the more time there is for these assumptions to have been violated at some point. Ironically, the dating techniques only worked with a high degree of accuracy for a few thousand years, which is
False. False. Depends on the dating technique, dude.
the creation model postulates for the age of the Earth. Let's think about these assumptions for a moment. Are they acceptable?
Yes.
Imagine for a moment that you're walking down the sidewalk and in front.
Oh shoot. Okay, he has this. I actually have watched this part. He has this really stupid example about a bucket losing water, which is not a nuclear process, so it's different. So let's not listen to it. It's very dumb. It's very dumb and not related to what we're talking about. Look, I will link this playlist in the description of my video. So if you guys really want to watch this, you are free to do so. But I'm not suffering through it. I'm not suffering through it again. Even for your joy and benefit. It's not even related to what. Gosh, excuse me. It's not even related to what we're talking about. Okay, dude. What else do you have to say?
Spray to the bucket. Then
Still talking about that bucket. I don't want to hear it. I do not care about your bucket, dude. All right, what's this?
have been empirically shown to be unreasonable for the same sort.
Ooh, oh, okay, I know. All right, I skipped ahead too far.
So your experiment was essentially worthless in determining anything,
Just like that example.
since your assumptions were incorrect. Radiometric dating techniques fall victim to the same fallacies. All three of the aforementioned assumptions have been empirically shown to be unreasonable.
Show me the paper, dude. Show me the paper. Show me the evidence. Show me the study. Talk to me about it.
Same sort of reasons. For example, concerning the first assumption, this is the equivalent of assuming the crack in the bottom of the pail always remained the same size, even though
Radioactive decay constants have never been observed to change.
activity actually caused the crack to expand. Is it reasonable to conclude that the nuclear decay rates of the elements have remained constant throughout
Yes.
history? No.
Yes.
Here is one example of how we know that.
Dick.
A team of
Sorry,
geologists
that's-
known
I
as
shouldn't say
RATE
that.
conducted extensive and notable research on this very idea, investigating the contention that nuclear decay rates have not been constant throughout history.
It's not a contention. And by the way, rate is a specific one. I looked them up, right? I cannot find a paper published by that research group in a journal, right? Um, and it's a specifically creationist group. So they're sort of already they've got some poisoning of the well going on there. Um, by the way, on the first watch through, this is where my brain broke. This is where I just could not handle it anymore, and I got like measurably dumber.
The rate team studied several zircon crystals from a drilling site in New Mexico. Zircons are considered to be some of the oldest minerals on the earth
Yep,
and are very
this is
hard and
factual. We
resistant
just
to
talked about it.
deterioration.
See, guys?
They're also thought to be able to preserve their contents well, making them safer from contamination. Using evolutionary dating techniques, the crystals were found to be 1.5 billion years old.
Sounds like a
The
good date for
problem
a
is that
zircon for me.
content analysis revealed that large amounts of helium were found to be in these crystals. Within zircon crystals, a portion of the zirconium atoms will be replaced by uranium. As uranium 238 decays into its daughter element, lead 206, alpha particles are released that combine with nearby electrons. Helium is formed, and that helium can be found in zircon crystals. By evolutionary dating techniques, the zircons the rate team studied revealed billions of years worth of decay from measuring the amount of daughter products in the crystals, but the helium concentration contradicts that information. Helium is
Okay, so everything most of what he said up till now is true. So when uranium, the main decay chain, the main decay process from uranium to lead is a series of alpha decays. I think I'll link I've got a series on different types of radioactive decay. I'll link it down below. And an alpha decay releases an alpha particle. What is an alpha particle? It's just the nucleus of a helium atom. So absolutely, helium is produced in the process that turns uranium into lead, right? Okay, and absolutely, that helium is then going to diffuse out of this rock over time. Um, and yeah, and it's a gas particle. So the picture, right, is look. Okay. These squares, think of that as like the lattice, the crystal lattice, right? It's my very bad drawing of this, right? I just made it squares for easiness. Okay, so let's say this was a uranium atom and it underwent an alpha decay and it released a happy little helium atom. I've got a pink marker right here. Helium should be pink, right? That seems right. Okay, so it released a little helium atom. I drew it kind of small, but there you go. There's a helium atom. Oh, happy day. And now that helium atom is just out of the nest and off on its own, off to have some adventures. And it's gonna like bounce around. So it moves in random directions. And let's say it goes here and hits a corner and then, does this, goes boop, boop, and then gets out of the crystal, right? Um, or here's the other thing though, right? It could have gone, maybe it went this way first and then it went back this way. So we're ping pong balling around, right? So maybe we first went over here and hit that corner and then bounced this direction and then bounced back up and then bounced this way and then bounced back this way and then went here and then here, right? All over the place. Look at all those lines I drew. And maybe then it goes down and then it gets out of the crystal, right? So a helium atom released from the same point, right, could, in what I drew, take 2 bounces to get out of the crystal, or like 10 bounces to get out of the crystal, because it's random motion. That's what a diffusive process is, random motion. Other things we know about diffusion, unlike radioactive decay, diffusion is heavily influenced by temperature. So the process speeds up with warmer temperatures. So um, This is the paper I found on issues of helium diffusion. Um, it's not even issues of helium diffusion. Here, oh no, sorry, this was their article. This was like the rate article, and it's on Institution for Creation Research, so it's legit. This is the actual article I found, I think. I hope I'm not lying to you again. Let's let it load. Okay, here we go. Yeah. Diffusion of helium in zircon and apatite or whatever. I might be hungry. I might need dinner. If I'm thinking that's pronounced appetite. Um, that's just another type of mineral. So what I read through this paper, I don't wanna necessarily show all of this. But no, this is a pretty old paper. It's from 2009, so it's pretty robust. So let's just take a look at the abstract. Um, Diffusion of helium characterized in natural zircon. This is how and then they heat it. Um, and what they do is they measure how much helium comes out, and that actually tells you something about the thermal history of the mineral, which I think is very cool. And so this idea that like helium is a problem for these dating methods, it's just not. So what he's about to say is that they found too much helium. So let's let him talk.
Known to behave as a slippery material. Helium atoms are small and are constant and in constant motion as gas particles, so they're hard to contain.
So that is true, but they are gas particles trapped inside this crystal structure. So it's not as free as it is like in the open atmosphere. And they're going to be able to move around. And they're also like they're small, but they're actually for a nuclear particle, they're pretty big. So small versus large, and it is going to diffuse geologically quickly. Like I'll give them that.
Fuse quickly. Here's the
I
problem.
have a hair in my
If the
mouth.
rocks were as old as the dating techniques suggest, billions of years old, and if uniformitarianism is true and the current rate of decay for uranium into lead is constant, there shouldn't have been such high concentrations of helium. It should have long been diffused from the crystals and released into the atmosphere. High concentrations of helium are thought to only be sustainable for a few thousand years without significant diffusion. So the presence of high concentration of helium illustrates the fact that at some point or points in the relatively recent past, the nuclear decay rate of uranium was accelerated.
So that's not at all what that implies. Not even a little bit, dude. Here's a great example, right? Can you think of anything smaller than a photon? How long do you think it takes a photon created in the center of the sun to make it to the surface? It's really small. It moves super fast, right? How long should that take? Turns out it's about 4.5 billion years on average. So just because something's right, when we're talking about nuclear processes, like again, that small versus large can be confusing. And also, it matters a whole lot if that helium is made in the center of the zircon or if it's on the edge. That's going to affect diffusion. The heating rate absolutely affects diffusion of it. And what's a little frustrating for me as a scientist here is that um, he's just telling me the results, right? He's just telling me how much helium was there. Um, not, he doesn't even tell me how much was there, just that it was too much. Okay, well, how much was expected, right? What methodology did they use to measure the helium? How did they arrive at the number of how much helium was supposed to be there? What's the thermal history of the rock they were looking at? So how fast should we have expected diffusion to have happened? Those are all questions I have. And here's the thing, even if there's too much helium, how could helium possibly get here? There are multiple ways for that, because earlier I was talking about like how in the world would you get extra lead in there? Well, lead is a lot harder to move around than helium. Lead is a solid at most temperatures, and helium is a gas. Guess which one is easier to move around, right? So there are processes by which you could think of helium diffusing through rock, helium being added or taken away. Um, and so there's a lot of so so all let's assume this study is perfectly right, and I feel like that's being overly generous to begin with, right? But let's just say that their methodology was good, there was more helium than expected. That doesn't mean what that means. All that means, the only actual conclusion you can draw is there was more helium than expected. It doesn't answer how that helium got there, right? It just says there's more than we expected. So he's drawing, excuse me, I didn't mean to hit my mic. He's drawing an unearned conclusion there. So that is also dishonest, and you should know better, PhD sideburns.
Producing larger amounts of helium that haven't had time to diffuse yet. So helium concentrations in zircons indicate a young age for the specimen with a period.
It is very important to note that the only group I could find that was like concerned about helium levels were specifically young Earth creationism groups. So there's something there, and again, there's not a reputably published paper, so you can't even like dig into their methodology. I think my next one of these videos might be reading this and suffering through it for your pleasure. For your pleasure. There we go. I tried to point too low. It wasn't at my camera. For your pleasure. This is a pretty picture of a volcano, but that's a nice lava flow. All right, keep talking.
Rapid decay rates, which harmonizes with.
Oh my gosh. Okay, sorry. He's killing me. Killing me slowly.
In which the fountains of the deep were broken up, surely including the releasing of lava onto the earth, would certainly affect the nuclear decay rates of the elements.
How? No, you can't just say that. That's nonsense. Prove it to me. Show me data. Show me data. Do it, do it, do it.
Concerning the second assumption, no daughter element existed in the specimen at the beginning of its decay. Comparing our water bucket illustration, this assumption is the equivalent to assuming that that bucket of water was initially completely filled with water. Remember that not only was the bucket not completely filled.
Not the same, because lots of things could cause a bucket to be more or less filled. Not a lot of things could cram lead into this specific crystal structure.
But at one point, water was added back to the bucket, making any assumption about the initial state
How do
of
we
the bucket
cram more lead
completely
into your
worthless.
bucket?
In the same way, common sense tells us that you
Common
can't
sense is not
assume that every
nothing.
rock on the earth was initially completely composed of a parent element. How can a person possibly scientifically prove
Guys, how could they possibly scientifically prove that? Chemistry. Chemistry. It's on Wikipedia. Gosh, dude. I'm getting mad.
thing, and how likely would such an assumption actually be? Parent and daughter elements from totally different sources could easily merge together in a lava flow.
This isn't formed in a lava flow. Zircons are different. That's because that's why we're careful about what minerals we date. Come on, man.
To make one rock that has parent and daughter elements at the onset of the rock's decay process.
Sure, for any old rock, but not for our very carefully selected zircons.
And subsequently giving the appearance of age. Again, a global flood in which the fountains of the deep were broken up would certainly contribute to the mixing of elements at the onset of a rock's decay process.
Please explain to me how like a bunch of water flowing results in like that doesn't how does flood turn into we made rocks, right? How does that work? How does that work?
Another factor that the bulk of the scientific community wouldn't even consider is that rocks could have initially been created already
comprised rather than all parent elements. Look, if you want to make an we're back to arguments from magic, so we're not going to listen to him talk about it. Like, could it have been made with apparent age or whatever he's going to say? Could the universe have been spontaneously come to existence last week? and sure, and I can't prove otherwise, right? It doesn't look like that, but I can't say for sure that that's not absolutely what didn't happen, right? So that's a nonsense, boring argument.
Directly, since they were and are an important part of life on Earth, not for the purpose of deceiving us, but because of their inherent usefulness. Bottom line, it's quite an assumption to claim that a rock was initially
No, it's not. It's really not, dude.
bought into the evolutionary propaganda and feel compelled to believe it.
Ooh,
As I've mentioned
ooh,
before,
oh, cutting me to the soul, cutting me to the quick, PhD sideburns. I've bought into propaganda. Like, I'm sorry, covalent bonds or propaganda? What, like, the most stable state an element can be in is when all of its outermost valence shell is full. Ooh.
don't get evolution out of a straightforward
No.
reading of creation in the account in Genesis chapter 1. Someone had to present information which caused you to distrust the creation account.
Dude, I just think that the creation account is a lovely poem. That's all I think it is. It's a lovely, lovely poem. You should let it be a poem.
Or made you feel pressured to accept evolution.
I do not feel
Bible
pressured. I
believers who
just feel
believe in
not
an
dumb.
old earth believe that dating techniques do prove an old age for the universe. That in turn causes them to question the account of creation given in Genesis 1. But old earth creationists that have bought into these dating techniques seem to have neglected the fact that God had to initially create the earth with an appearance of age in order for it to
Why? Why is that a thing that had to happen?
be fit for human beings.
Why?
For example, light from stars that are billions of light years away had to be
Why?
already in place in order for it to be
Ugh,
used in first day
this seems dumb. This
215.
seems like theology and not science. Um,
They needed to sustain life. They would likely have had rings in order to be able to support the size of the mature tree.
See, I actually disagree with this idea that, like, if you cut down a tree in the Garden of Eden, tree rings form by periods of like growth, and then we stopped because it's winter, and then we grew, and then we stopped because it's winter, and then we grew. So that's what causes the rings to form. So if like God or Gandalf made a tree instantaneously, there's no necessary reason for it to have rings, right? It should just grow continuously. Unless there's some like time magic happening that's like, I don't know, a time dilation field where time's moving more slowly for the tree than it is for us, so that it can grow the rings. But if you cut down a tree in the Garden of Eden, it shouldn't have rings unless they were intentionally and frankly deceptively put there. And that seems so unnecessary, right? That seems so unnecessary and much more of a problem for you there, PhD sideburns, and trying to understand why your God would intentionally lie to you. You don't have to believe that. I think I said this before. The majority of scientists are people of faith, and there's no issue here. Like, you're making an issue that doesn't need to exist. Um, and if you want to say that, like, I know what the evidence says, but I believe the Earth to be young anyway, again, you're free to do that. But the issue here is that you're claiming that there's scientific evidence to support your claim when there isn't, right? You're free to hold any belief you so desire, but if you start bringing forth scientific claims, well, then you've got to participate in science, and you've got to do the thing. You've got to prove a claim. You've got to bring evidence, and all that jazz, and you're just not doing it. So I'm not here to poo-poo on anyone's beliefs, right? But we're not. This isn't about theology. This is about science. These are different fields. Anyway,
Since rings help provide strength as trees get bigger and older. Daughter elements would have likely been present in
why?
rocks,
What
since the
purpose?
daughter elements serve purposes on the earth other than showing age. Well, once these things are considered, a fundamental
That's
assumption
silly.
of
This is
radiometric dating
silly.
techniques is totally
This is silly. You can't answer that. Like, science answers like natural questions, right? So like, how did lead get there? You Science has no ability to point to a supernatural answer, right? Has no ability to point to magic. So all we're going to do is look for natural processes, things that are predictable and repeatable and understandable and testable. And so you can argue for magic all day long, but it's not a scientific argument. Okay. Oh, all right, all right. I'll listen to his third assumption critique. I'm getting upset. I'm getting frustrated with him.
Assumption: the item being dated has never been altered by anything except radioactive decay. In other words, this assumption
And specifically what we mean, what the assumption more specifically is that the relative concentration of parent and daughter isotopes in this specific mineral that we're interested in were only affected by radiometric decay.
is that we have a closed system on the Earth. That's the
No?
equivalent of assuming that the pail of water was never affected by anything other than the small leak at the bottom of that pail, rather than realizing that a dog jumped into that bucket of water and water was added back.
What's the dog equivalent to how would I get, oh, wrong picture. What other process, specifically what other process would either add or take away uranium or add or take away lead from a zircon? What is the dog in this analogy?
The pail through the use of a hose. Again, you can see such an assumption is simply unreasonable.
When we're talking about
Assume
dogs and
that a
buckets,
rock
sure.
that's being dated has not ever been affected by outside forces throughout its entire existence.
So that's not saying that like the rock never weathered. That can happen. That can happen, and the shape of the rock can change, right? It's this relative abundance of these different elements. What again? What process is going to change that? Please explain it to me. Please tell me, good sir.
No leaching, no water or other substance ever soaked into a specimen and carried off part of an element or added to it, contaminating it. Again, natural catastrophes would certainly affect such an assumption.
Water. How would? No, that's not how that's going to work. It's just. That's not. That's not how any of this works.
And such catastrophes are not uncommon today, much less a catastrophe on the scale of the global flood.
But you
Without
have no
these
evidence
assumptions in
actually
place,
happened.
the
Come on,
Earth can't be
man.
dated scientifically, and that bothers many scientists. So
What? What? No, this is nonsense. This is really nonsense, guys. We don't ignore issues with the assumptions. Like I laid out those assumptions before he did. These are not ignored. These are acknowledged, and that's why we don't date any old rock. Right? A great or organic material. A great example is there's certain like shells, so things made of like carbonaceous no, wrong thing. Oh gosh, calcium carbonate, that's the word I want. Carbonaceous chondrite is a type of meteorite. Anyway, calcium carbonate, those certain shells. So oh my gosh, sorry, I'm pulling this way back from the recesses of my brain. So there's certain types of things like shells and things that you can't use carbon dating on because we know the ratios in those are like different. They're affected by other things, right? So we don't date those with radiocarbon dating. So there are places where these assumptions that we laid out don't work. So we don't use the method when the assumptions break down. That's not a thing scientists do. And if somebody makes a mistake and accidentally does that, it gets caught pretty darn quick. It's that's science. That's how it works. No, no, no. You're hurting my brain, PhD sideburns. Oh, you're hurting my brain with your nonsense.
ignore the issues with those assumptions and do the best they can to date an item. But these assumptions totally destroy any attempt to date materials that are
No,
very old because those
no,
assumptions simply cannot logically hold.
no.
It's simply unscientific to ignore the issues here.
False.
The truth is, there
Lying.
has
You are a
been
lying
such
liar.
catastrophic events over the years that make it impossible to use
Good
these
draw.
techniques to date the Earth. The only way to get an age for the Earth is through divine revelation. That said,
That's your argument. That's your science versus evolution, like mic drop argument. Divine intervention is the only possible way. Nothing, no other possibility could possibly exist. It's the only thing. What? How? How is that? That's not science then, right?
Geology through the lenses of the creation model is a fascinating study, and it's in keeping with the evidence. Much
No, it's
good could be
not.
done if geologists would look at the evidence and interpret it in light of biblical statements. The great
No, much good would not be done if we did that. No good would be done if we did that. How do I know this? Because it is bad science to start with an assumption, right? I think PhD sideburns would agree with me on that. No good science starts with the conclusion, right? He even said at the beginning of this, we're going to take a look at the evidence and follow it where it leads us, right? But if you say, but what he's proposing here is not that. What he's proposing is, well, let's start with these list of things that we have to be absolutely true, can't be wrong, um, no matter what the evidence says. No matter what the evidence says, these things can't be wrong. So we'll go from there. That's a really terrible way to approach science. It's really, really bad. You're gonna get bad results. So no, geologists don't do that. I think we might be straight into just preaching. Or maybe talking about, oh, okay, what's the bottom line? Let's take a look. What's your bottom line here? Bible gives plenty of evidence. No, still harping on that uniformitarianism thing that again I had literally never heard of. I've done science every day of my adult life and most of my non-adult life, right? Um, has been sent doing science, math and science. It's all I do. And it took PhD sideburns to introduce me to this term. This is a nonsense term. This is not real, right? Or it's so old it's and out of date as to be irrelevant. So it's no, gosh. All right, I'm done. I'm done with you. I'm done with you, PhD sideburns. I'm going to stop sharing. Hello there, good people of the internet. I hope you enjoyed this. I really do. Thanks for coming and hanging out with me. Um, Please let me know down in the comments what you think. Is this the type of video you'd like? Would you like me to do it as a live stream? That kind of thing. I'd like to hang out with you guys some more. We all could use some socially distanced human interaction. But I hope you guys are well. I hope, yeah, I really do. I really do. I've had a rough year. I'm sure you guys have had a rough year. And we should, just be together and spite it. Okay, team. So please like, subscribe, all that good YouTube stuff. And I will see you next time. Okay, bye.